Hello guys, welcome to the channel once again. So in the last video we looked at ports and protocols, and in this one we will be building on that knowledge and we'll be talking about firewalls. A firewall is basically a network security control system that monitors and filters traffic based on predefined rules. So these rules determine which traffic is allowed onto a network and also which traffic is allowed out of a network. What a firewall does is basically inspect your traffic and decide whether to allow or block it. It operates mainly by analyzing packet metadata or the packet headers, checking information such as the source IP, the destination IP, the port numbers, and also the protocols being used, and then determining whether to allow or block the traffic based on these IPs, ports, and protocols. So in a typical firewall implementation, every incoming and outgoing data packet will be evaluated against the rule set, and these rules will define whether to allow or deny the data packet based on the IP address it is coming from, the ports, or the protocols being used. So the firewall literally becomes a wall between the network or the device it is established on and the outside network, checking each traffic as it comes and goes against the set of predefined rules. So an example of a typical firewall rule would be to allow TCP traffic from port 443 onto a network, to block a specific IP, and to block an insecure protocol like Telnet. So in that case, any connection that comes from port 23, which is usually for Telnet, will be blocked by the network immediately, and any connection that comes in from port 443 would be allowed, because that is what has been stated by the firewall rules. So to better understand the different types of firewalls, we will look at them in pairs. So in the first pair, we have stateless firewalls and then stateful firewalls. So the stateless firewall is designed to do just basic packet filtering. So in simpler terms, this firewall would compare every outgoing or incoming traffic to the set rules. If the rule states that the traffic should be allowed, it gets allowed. If it doesn't, it gets discarded, or it results to a default, which is almost always denied. So this firewall is fast compared to the other ones because it has a relatively simpler job, which is just inspect or compare the traffic against the set rules. If they match, it gets allowed. If it doesn't, it gets discarded. But with the advantage in speed and simplicity comes the disadvantage of it being less smart, which we will find out why in the stateful firewalls. These firewalls take a different approach at enforcing set rules. Looking at an example rule that states that the firewall should allow inbound traffic on port 80. Let's take a look at how a stateful firewall is going to enforce this rule. So first of all, in earlier videos in the playlist, we talked about the TCP IP model, where we looked at the transport layer, and we learned from there that for a connection to be established, there's going to be the TCP three-way handshake. So back to our network where we have our firewall in place. Say a device within the network is to establish a communication on port 80. First of all, with the first packet, which is going to be the send packet from the device to the server to establish the connection, the firewall is going to create a state table, and in this state table, it is going to save some very important pieces of information such as the source IP, the destination IP of the packet, the source port, the destination port, the protocol being used, and the connection status. So now with the reply packet from the server to a device, which is the send ACK packet, the firewall will now take this packet and compare it to the state table. And then because this reply packet is going to be addressed with the same IP and port numbers with the same protocol, the firewall now knows that this packet is part of a known connection and then updates the status to establish. So now every incoming or outgoing traffic is not just going to be checked against the rules, but they also be checked against the state table to make sure that they are part of an established session. And this right here makes a huge difference, because in the stateless firewall, it has no way of knowing if the data packet is part of a known connection or not. So if an attacker is able to craft a malicious packet, spoof the source and destination IP addresses, and then put the same port numbers, in the stateless firewall, it is going to get allowed because it just checks it against the rules. But here in the stateful one, it will not only check to see if the packet matches the rule, but it also checks to see if the packet fits into the known connection. And that is a crucial difference between the stateless firewall and the stateful firewall. So first of all, let's look at the application of the proxy firewalls. So these firewalls perform what we call the deep packet inspection, and here's a brief of how it works. So say a client within the network wants to establish a TLS connection with a server. This firewall will intercept that handshake and open a new TLS connection with the server. So the whole communication process between the client and the server passes through the firewall. So now this will allow for the implementation of more advanced rules. So now we can implement rules based on the content of the data packet. So in this case, we can block certain URLs, we can block certain types of requests, we can scan for malware, we can log requests and all other stuff. So that is how the application of the proxy firewalls work. They basically work as true man-in-the-middle attackers on the network, but in this case, the average attackers, they are trusted and controlled by the network administrators. So also with a huge improvement in the security will come the performance impact. So because this firewall basically re-encrypts the traffic between the client and the server, it is very CPU intensive. It can slow down the network. So in a way, this application of proxy firewalls behave just like the custom officers at the airport. So just like the officers, they can intercept your package, open it and inspect the content, make sure it abides by the travel rules, and then reseal it and let it continue. So just as we trust the officers because they are authorized to do their work, it's the same way this firewall is also authorized to perform this deep packet inspection on every single traffic on the network. But of course, this can also raise privacy concerns for users in the network or organization. So lastly, we have the next generation firewalls, which combines the traditional stateful firewalls functions with advanced security features. Now these features include intrusion prevention systems, encrypted traffic inspections just like the deep packet inspection, and advanced threat protection systems which can block malwares and also detect suspicious behavior. So these firewalls can implement more complex rules such as allowing HTTPS traffic but blocking some specific applications from using it. So looking at the placement of firewalls within the overall security architecture, firewalls can be either host-based, they can be network-based, or they can be even cloud firewalls. So as host-based firewalls, they can reside on devices, on computers, on laptops. On the network level, they can reside on routers, and in the clouds, they can reside on virtual environment. So in conclusion, we've seen that firewalls are not just applications or settings we turn on and off, but they are rule-based decision systems. Thanks very much for watching. Please subscribe to the channel if you haven't, like this video if it was helpful to you, and also consider sharing and then leaving your comment in the comment section below.